question is, what's the pressure on this lecture, though? That's the biggest question.
All right, good. Let's start. I guess first there might be like some questions regarding registration and what's the mode. So let me first clarify. So the course is mandatory S&C, but it bears full credit. So that means basically it will have like 1 credit, because that's what full credit at Brown means as far as I'm informed. So do you have any questions regarding registration or any of the logistical proceedings? No? Okay, cool. Yeah, if you have any, just contact me or like one of the TAs and we'll try to figure it out. I mean, the reason why we decided to make it like mandatory S&C is basically because it's a new course, and to make it kind of not too stressful, like grading and so on for you. All right, then let's start. So before we dive into the content, I want to first give like 2 erratas on slides of like the first and third lecture, which were pointed out by someone on Piazza, which is always great because given it's a new course, the material is new, so there might be errors. So be always careful and point them out, and we'll try to figure them out. So basically what it boils down to is like, when I was like writing the slides, I mean, you see I am an addict of like the company which loves to have a fruit logo. And so I just use like kind of this command, which I use daily, and it's like list -g, because it displays colors. However, when you actually run that in a shell on like a GNU Linux system, you need a different switch, and that's like the -- color switch. And so, well, why is that this is like not the same? Well, the reason basically for that is like, when you remember from the first lecture, we had this big tree of like Unix derivatives, right? And there were like basically 2 branches. One was like the Berkeley software distribution branch, which resulted in like kind of the Apple systems, like Mac OS X, iOS, and so on. Then we had one branch which was kind of separate, but not directly coming from there, and that's like the GNU Linux branch. And so basically, though they have like a lot of similarities, there are sometimes like some differences in the details. And this is exactly one of these differences where basically Apple decided to override the meaning of the capital G a little differently, and I just assumed it was the same. So if you're working on GNU Linux, just use list -- color, and if you're working on Mac, you can just use -g. However, the bottom line of the story is basically always check the man page on your system, and still, I mean, you basically want to use your own system, so both solutions are like fine. The second errata is considering one more of these like tiny differences between GNU Linux and BSD. And so when I was like introducing the trailing slash and saying like, well, there are like some commands which account for the trailing slash and so on, it actually also differs across these 2 systems. So in kind of the BSD branch, the trailing slash in the copy command is accounted for. That's why there is the kind of this odd behavior, and you can write copy -r folder / and then dot, and then it basically puts it up one directory. Whereas like in GNU Linux, the copy command was just shipped will complain, and yeah, it doesn't work. However, thankfully we already learned about like Unix wildcards, and so there's basically one easy way to mimic that behavior. You just have to append a star to select basically all these files after the slash, and then you get there too. Cool, then let's move on to like recap of our last lecture. So last lecture was all about file permissions, how to protect your files, how to make sure that Tux doesn't realize that C-line actually eats penguins, and so back and forth. And so when it comes to file permissions, we basically learned like that you can protect them. You have like kind of these 3 parties. You have user, group, and other. And for each of these groups, you can give them read, write, execute permissions. There were also like some special permissions, which just gave like a little more variety and were useful for like some special use cases. However, the gist out of it is that you basically have sometimes to modify the file permissions to run stuff, to read stuff, to write to files, and you can do it in 2 ways, the symbolic mode or like the numeric mode, by basically just giving the numbers. And so when people say like, hey, I need 650 permissions on a file, then this basically boils down to the user has read-write access, the group has read-execute access, and the others have no access. The other thing we were looking at in the last lecture were streams and pipes, and so that basically boiled down to like, where are commands actually getting their input from, where are they handing their output over, and there are basically three standard streams. There's a standard input, a standard output, and a standard error. So basically, command always takes input from standard in and writes it to standard out and or standard error. And the cool thing about these streams is that on one hand, they provide an opportunity that we can pipe multiple commands together and like combine them like Legos to form like more powerful commands, or just have like fancy one-liners. And the other cool thing is that we can redirect streams to and from files. And speaking of that, we can actually do a little more fun stuff. And that is like a little more on stream redirection. So let's see how this works. So when we start a command, the basic setup is we have our three streams, and they all redirect to the terminal, or come from the terminal in the case of standard in. And so the first thing we can do is, as we learned in the last lecture, we can just like put them into separate files, which is like this example. Here we have some command. The standard output goes to standard out.txt, and the standard error goes to standard error.txt. However, we can also do something cool, and that is we can actually point both output streams to one file only. And because we combine them, we can basically just use the ampersand and redirect them to the same file. And that's actually safe, so you don't have like weird character overlaps or so. So it's like an atomic redirection.
So
Yeah.
Command and what are being redirected here?
So this is basically a shortcut to direct both standard out and standard error to out.txt. So both streams write to the same file. However, they don't kind of interlap the characters. So for example, if this writes hello and world, you will either have hello and then world, or world and hello, but you won't have like some mix-up of the characters. So basically the write is atomic. There's also another option, and that is we can also redirect one stream to the other. In this case, we can redirect the standard error to standard out, and then we redirect standard out to out.txt. And like the thing to keep in mind here is like when we look at this command, like command, then redirect to out.txt, and then 2 redirects to 1, and like 1 is now referenced using like the ampersand. We have to read it like from left to right. So basically first we set out the standard out to redirect to out, and then we set up the standard error to redirect to standard out. And if we flip that, then it basically doesn't work, because then basically standard error would just print to the terminal, because we kind of did not set up the redirection yet.
Wait, do you say that?
Okay, all right, so maybe, all right, so the basic thing is like first in the command, we set up standard out to go to out.txt. So the standard out points to out.txt. Then we set up our standard error to redirect to where the standard out redirects, which is in this case out.txt. However, if we flip it and we make something first, like we redirect first standard error to where standard out redirects, this is still the terminal. So standard error goes to the terminal, and then we redirect standard out to like the file, then this basically stays in the terminal, because it's not like kind of a strong reference, which that would be like in a programming language. All right, there's one more other use case I want to share, and that is like something out of like the practical systems toolbox. And I mean, personally, when I kind of run experiments to benchmark systems, I often have like some long-running jobs, and I want to log the results, but also see what's going on at the same time. So basically what I need is, I want to redirect whatever the program writes to my terminal and also to a file at the same time. Luckily, there's a cool way to do so, And that is by using the T command, which does nothing else than it reads from standard in and writes to both standard out and file. So you can basically see it as like a multiplexer, which puts it on two streams. And yeah, you can also like tune the behavior that it appends to the file by using the -a option. And so in order to kind of lock everything to like out.txt and write at the same point to terminal, you can basically just use command, and then the 2 goes to like &1, and then just pipe it to the T command. Yeah.
So when you're running to like standard output, does the
Yeah.
standard output also include like an error? Like for example, like if you have a program that you're running which return like prints 1 + 1, then it's also gonna print 1 divided by 0. Is it gonna print 2 and then an error for the standard output?
Yeah, so that's like all depending how you set it up. So here in this example, I basically put the standard error to go to the standard out.
Mm-hmm.
So then I basically have this case here, right? But then I know like, okay, everything is now going to standard out, but when I pipe, the standard out of the previous command is connected to the standard in of the next command, which is in this case the T command. And so the T command prints it again out to standard out, but also locks it out to a file. So I have done exactly this scenario where basically locked all the streams to a file and the terminal.
Yeah, so there's a way you could just like have 2 files. One is like just whatever the program will print out, and another one is just whatever errors it'll throw.
Yeah, you can do that, but what kind of the problem here is like you can't kind of do the 2 redirections, right? Like because you can basically just not display the errors and like just like lock them out to a file, and then only have like the standard output, which would be like if you just do like 2 goes to like some file, right? And then you basically T just the standard out, but you can't do like both. That's kind of the only problem. But like, I mean, in the end, that's kind of the problem. But like, I mean, if you really need such special behavior, usually the best way is not to use like the T command, but to set up manually where to lock what things. Great. Then let's go to the fun stuff, and that is scripting. So till now we basically just had like single commands, then we have like multiple commands which we can combine using pipes. However, to make the whole thing more interesting, what we really want to do is like write scripts, save commands, and reuse scripts to make our daily life better and easier. So before we dive into how to actually write a script and what the basics are, let's talk a little about like shells. So far I was always like mentioning, you know, we have a shell, we have a terminal and so on. But what's actually going on when I type stuff? So basically, when I start my computer and I just get like a command line interface back, this is called a shell. And a shell is nothing else than one process that was like just chosen at startup time to run as the first process, and provides me basically this command line interface to the operating system underneath it. So it's just a program. And what this program does is now it basically sets everything up so it connects to your keyboard via the operating system and so on. And so you can basically type your commands, then it analyzes them, parses them, does something which is called expansion, which is basically all the fancy stuff that we did with like curly brace expansion or wildcards. And then finally it executes it with like a mixture of built-in commands, so things that are just run by the shell itself, and calls to like the operating system, here represented basically by the kernel. And another option is that it can run external other programs, which are like many commands, like for example list, cat, grep, and so on. So this is basically the basic structure, what's happening when you start a computer just in command line mode. So is there one shell? Well, when it comes to Unix systems, the answer is there's pretty much of anything multiple versions out there. That's just because people love to build stuff, and also like, I mean, it's all open source software for the most part, and thus it is like an iterative, incremental improvement process. And so how the whole thing basically started is that there was like one shell which was quite popular, which is like the Bourne shell, which was developed in 1977. Then from that, like there were a couple descendants. We have like the corn shell, C shell, a 10x C shell, which is an improved C shell. We have a C shell. We have the fish shell, which is like the friendly interactive shell, which is a quite recent development. It's only 15 years old. And basically what it boils down to is like, what shell should I use? Well, the answer is like, it's basically your choice. So you can choose and use whatever shell you want. However, in this course, we are basically focusing on one particular shell, and that's like the Born Again shell, or short BASH, which was developed 40 years ago. And the reason why we choose this is that basically it became a de facto standard and is just widely deployed. However, there are like always like different flavors, there are different versions, which means like you always have to basically check the man pages to see what's supported or not. However, there's like some basic set, and that's basically the set we are going to learn in CS6. So what's Bash? Well, I already mentioned it's one of the de facto standards. You can read pretty much everything about it. It's a very, very long document by running man bash, so to bring up the manual page for bash. And it's typically stored under like one specific path, and that's like /bin/bash or like user bin bash. And that's like the actual command and then runs like first. So the shell. So why should we care about scripting? Well, yes.
Until now we were talking about putting in commands in the terminal.
Yes.
Before you introduced bash.
Yeah.
So wasn't that also using a bash shell that whole
Yes,
time?
that's basically a bash shell. Yes, because so how it works is like when you start a terminal, you can actually define which shell should start by default. So for example, when I'm
So terminal and shell are two distinct concepts.
Yeah, well, that's it. It kind of gets now a little in the details. So some people would say it's all the same. However, it can get a little different when you work remotely. So when I start up on my computer a terminal, this is basically a program like the nice graphical user interface, which runs internally either the shell or displays me output that it fetches from a shell that's running on another machine. However, there's also the option where you kind of have your Unix computer or Ubuntu, Linux, whatever you want to use, and you just disable the whole graphical user interface, and it starts up in like a basic mode where you really work directly in the shell itself. Meaning, there's basically I mean, it's a little going into details, but like when you have a computer and you start it, there's like two initial programs that are always shipped, typically stored on the main board, and that's like either the BIOS or the UEFI, which is like the new version of BIOS. That is the basic input-output system. And so what this does, it just displays characters. But the actual program that kind of decides what characters to display is the shell in that sense, which is then loaded at startup time. That's like the command that's running. Hope that clarified a little.
So the BIOS is the interface for the shell?
Well, the BIOS is just the code that displays characters on your screen. But the shell is what decides what characters to display and like also takes the input, runs the whole REPL thing, and provides you ultimately a command like an interface to your underlying system. So yeah, speaking of that, so let's say I'm right now here in my computer, right? And if I want to start the shell, I can basically just run bash, and that starts my shell. So now I'm like in the shell bash, and you see like here my prompt kind of changed. I can also exit that by using just exit. I can also start a different shell by using, for example, sh just for like the Bourne shell itself. So now I'm like in a different shell, which I can also exit. Or I can do like more esoteric shells like the corn shell. So again, I have a different prompt now, which I can also exit, or like things like a C shell, and you see again like kind of the prompt changed. So this is like basically how I can switch shells during the time. However, when I start my terminal, a default shell is chosen, which is usually on like GNU/Linux or macOS Bash.
Learning then why this the prompts change.
That is because I can install multiple versions of Bash. So there's basically one system Bash version, and I have like another Bash version installed. All right, so let's go back to like why we should care about scripting. Well, first of all, it helps us to automate daily tasks, like we want to run a daily backup, for example. The other important part is we can automate all sort of system administration. That can be like we can write a script. Please fetch all software dependencies that we need. Like for example, you want like a web server to be fetched, you want like a couple libraries to be fetched, and so on. And what's like more interesting is we can also use it to actually configure our system. That can be like during startup time, or for example, if we want to run a service like a web server, and we can like create technical users, give them the permissions, and so on. And that's like what really, really makes the whole thing very, very powerful. And that's why it's like kind of worth to learn the sometimes, to be honest, a little awkward syntax that Bash provides. And the last reason I just want to mention specifically is that often when you actually deploy your software, which can be whatever, a web page or like a C program or a Python program or whatever you want, you are required to actually write a wrapper script, which is nothing else than a little script that calls your program with the right parameters. And you usually write these scripts also specifically for one type of shell. Yeah.
Did you run a shell script or like a bash script without having to run your terminal?
That's a very good question. So my answer to that is like practically no, theoretically yes, because it boils down to like if you have too much time and you did something as like one of the famous persons did who wrote Unix and like also like kind of the C programming language, you can go the route down of like, hey, I have a video game, it runs a little too slow, I want to write my own operating system. Then you say, oh, Bash is actually a cool idea, so let's re-implement Bash in like pure assembler. And then you could run it theoretically without a terminal and without a shell. That's like predefined. But however, for practical reasons, it's always like, when it comes to software development, first spend some time looking out, is there a good solution existing already? And if you think there's no good solution, then you should start writing your own better solution and share it to the world as open source software. And else you should better just reuse what's out there, because probably a lot of brain thought went into that and making it very efficient and practical to use. And that's basically what a shell also does. All right, so let's go to the basics of writing scripts. So what are scripts? Well, scripts are in the end nothing else than text files, so you can create them and edit them using Vim. Though, of course, like files on Unix are not always having like an extension that reflects to their content. For shell scripts, the commonly used extension is .sh, like for shell. And the next important part is how can we actually execute a script. So in order to execute a script, we basically need to give it first the right permissions, meaning the user or the executing user needs read and execute permissions. And then there is a couple options how to do that. The first is we can basically just use whatever shell we want here, in this case bash, and then just run the script with it using like bash script.sh. Or we can use kind of the short syntax of executing a file in Unix, which is just like / and then the file name. So that executes it if we have execute permissions. And when it comes to like kind of the short syntax, there is now one tiny problem. And that is like, I already mentioned there are multiple shells, many different ones actually. So how should the operating system know which shell to use to execute a script? And so, though this is kind of open, there is like some fix that was like deployed for that, and that's like we can basically add a special syntax for the first line, which is the so-called shebang line or like bang line. And that is nothing else like a pound sign and then exclamation mark and then the path to the shell which should execute the script. And so that basically is just a fix or hack for the system to look up which shell to use to execute the script. So let's have a small example of a script. So we basically have here a file, hello-world.sh. We have here the line which specifies that we want to execute it using bash. And then we have here a couple of comments. So comments is everything basically that starts after a pound sign is treated as a comment. And then we have two commands. We have clear, which resets the screen. And we have like an echo, which basically prints out hello world. So of course, I also want to demonstrate how that works. So again, we just go into like GNU Linux machine. Then we open the file up. We can basically now add the shebang line. And then I think the first command was clear, and the second one hello world. So we can do this. We save the whole file. And now we want to execute it. Okay, anybody an idea what will happen next? Sorry?
Just says hello, or whatever you typed in there.
Yeah, okay. Actually not. So it says permission denied. So what do I have to do now? Oh, source it. Okay. Okay, yeah, that works. However, that does not really what I want. So how can I fix this here? What should I do? Yeah, and what do I do for chmod? Yeah, so you add basically execute permissions, which is the usual thing that's missing. And so, I mean, you can, yeah. However, like for like one of kind of the most frequently used kind of chmod commands is actually +x. It's just to kind of give it quickly execute permissions. So, and the reason why I'm putting here, so 700 definitely works. No questions asked. Is that you will just encounter this a lot when you read whatever Stack Overflow entries and so on, or just scripts from other people, and that's basically the usual process. And now I can run the script. Yeah.
So what is the source for that?
We will clarify that in a couple slides. Yeah.
Would it have done the same thing if you ran chmod +x and then just home or hw.sh without the /?
Yeah, you mean? Okay, wait again. So chmod +x and now?
Just hw.sh.
Okay, so I mean this just like changes the permission, right? But then I want to execute the actual script itself, which I do by like dot slash hwsh. Okay. All right. Yeah, and that's exactly what kind of is also on the slide. So you can give it the permissions, right? Actually, 500 is enough. You don't need per se write permissions, and then you can execute the whole thing. Yeah.
Everything after a hash sign is a comment. Then
yeah.
Why is the bang beginning meaningful to the program?
Exactly. That's a very good question. And so the answer to that is like, it is actually just a comment. So if I force the script to be executed with a different shell, I mean, it will make errors, right? Because it's probably not written for that. But then it might just interpret this exactly as a comment. However, when I don't specify a shell, the operating system will look up the shell through like this comment line basically and execute it through that. So in the end, it's not a semantically meaningful element, it's just a hack which is stored in a comment. If that makes sense. All right, there's also like an option to actually write multiple commands in one line, because like when we looked at like kind of the first script here, it was pretty straightforward. We just take like kind of our file and then we write the commands in separate lines. But in fact, we can also write all of them in one line if we wanted. And the way that works is we just separate them using a semicolon. And this actually also works directly in the shell. So, or here like in my terminal. So for example, I can use print working directory as we know, but I can also run it like twice by just like separating it using a semicolon, which might be sometimes handy if you just want to squash more commands into one line. All right, let's go to source. So what does source do? So source, as we saw, also executed our script. However, it does something different.
Wait, what if you get an error when like in like the middle when you have semicolons? What if one of the commands gives you an error? Does you just stop the rest of it?
No, it will still execute through because it's basically just command separated. So of course, if your command would kind of exit the script, if it's like an exit command, it will stop, but else it would just run through. So it would just produce errors because you always have to think like, what happens in the error case? Like usually, error will just get printed to standard error, right? So you could have multiple commands running, and like everything that errors just has like an error message in the standard error string.
You keep getting an error message if the
Yeah.
first one has an error message in it.
Exactly. So it's kind of not like an early failure.
Okay.
Yeah.
What if you like remove execute permissions before it's done?
So you mean like for the script file itself?
Means-
I mean, then I can't execute it, right? Because then when I type like /, it will just like complain about permissions denied.
But if there's stuff before it, does that stuff execute?
S-
Like inside your script file?
Okay, so there's like two ways, right? Like one is like the script is basically just a collection of all the commands, and then when I execute the script, it just runs all these commands in a subshell. So if some of them fail, I mean, they write to standard error and the execution continues. However, they might fail, of course, if I didn't give them the correct permissions. For example, if you have in your script a copy command and you want to copy something which you can't read, then this will fail.
I'm saying execute permissions of the script file.
Yeah.
Okay.
But you give that once, right?
Yeah.
And then you execute it. So this is like kind of atomically. And it's executed in a separate shell or like run by a shell. So, I mean, if you override it like off your parent calling file, I mean, it's kind of a hack, right? Then you still have it in a separate process, so it won't affect the like parent process who called the script. Okay, so what does source do? Well, so source runs the script as well, and it's kind of helpful if you want to store multiple commands in a file and just like run them in your shell. So what source does is basically if I type print working directory and then cd, I could write those two commands also in a file and then source the file, which would be nothing else than if I was just typing these commands into the shell or terminal here directly. So this is what source does. However, there's like some more differences to running a script and sourcing a script. And to understand these, I want to talk about variables first. So variables, as you know, are like kind of the bread and butter of writing programs and scripts. And so how do you define them in Bash? Well, you just basically give it a name or an identifier, equals, and then some value. And please note that there is no white space between it, so you just have to write it in one line. And as always, there's like some conventions how you should name your variables or your variable identifiers. And that is like they should have like alphanumeric characters or underscores only. For Bash, they're also case sensitive, and there's one special case, and that's like you can basically define a variable which has no value or like an empty value, and you just do that by writing variable equals and then nothing. So you basically set no value in it. And there's not a mandatory naming convention, but one that many people use, and that's like to write variable identifiers in general in capital letters. And so if you come across script code of like other persons, that's why you usually see variables being named in capital letters. However, it's not mandatory. So how does it work? Well, we can just define a variable, like here, a variable dest, and then the next question is how can we actually access the content of a variable? And to do so, we basically use the $sign. So we have kind of here dest, and in dest then there is like home tux stored, and we can use it by just like using cd and then the variable name with like a $sign. And the same goes like for a message. So just to quickly demonstrate it, we can do like a message, use quotes to allow for white space, and then we can just read this variable by using the $sign. The next question is, when it comes to variables, is always like, where are they actually stored, or in which scope are they living? And so in Bash, we call scope the environment. So the environment is nothing else than the place where all variables are stored, like one specific name. So if we type, for example, just variable equals value directly in the shell, then a new variable with the name variable is added to our local environment of the shell. And the same kind of goes when we write such a variable declaration in a script. We just have there then the variable added to the local environment of the script during execution. However, something interesting happens now when we execute a script using the bash shell. And that is, like, whenever we invoke a script, the bash will export its global environment to the script. So that means basically, I first was talking about there's a local environment, and there's also another kind of sub-environment of the local environment, and that's the global environment. And that is variables that are destined to be exported to the script. And so how does that work? Well, we can either just run the command export variable, which will add the variable from the local environment also to the global environment, or we can just do it in a one-liner, where we basically export a variable with a value here in this case. And besides variables we kind of declared, there's another set of predefined variables called shell variables, and these variables are always exported to a script when it's invoked. And we can see what the global environment is by just running another special command, which is called print environment. So let's check how this works. So if I type printf, I see a list of variables that are predefined in the shell. And there's actually a lot of useful stuff. For example, I see here language is c.utf-8. So what that tells us is basically that our shell has a UTF-8 encoding. The user here is tux, so that's like basically the one I use to demonstrate stuff here usually. Then we have pwd, which is the current working directory. We have home, which refers to a home directory, and we have a couple more variables which are interesting but not that important for now. And so the cool thing is, because they're all predefined, we can also use them. So we can, for example, just echo the home location. We can also do this for the user. And when we invoke a script, as I said, we get all these variables for free, which allows us to do something cool. For example, we can write a script. Let's call this Hello World 2. And here we just have to add this again. Now we can say, okay, the user who invoked the script is, and then we can just output the user. So again, we have to add the permissions and invoke it. And we see that tux is actually the user who invoked this script. So as I said, there's a couple useful ones. We have like home, user, shell, and print working directory. And we have a couple more. And what we can also do now is, as I said, we can add variables to the environment that's exported to the script. So if I define here a new variable message, I can say whatever text like cline or so. And then I can export this variable. And so when I go now into my script, I can basically just add here the variable And so I see now here that the message is because I exported basically the variable to the environment of the script. So export does basically this thing. We can add the variable to the global environment, and then it gets sent over to the script, which has its own local environment. Yes?
What happens if you have it in your script like a variable, but it's not actually defined as a global variable?
So it's not defined.
Yeah.
Then it will be like an empty variable, so it has a null value.
Okay.
So nothing will be printed here. Okay, and so in contrast to this, yeah.
Why is global environment within local environment? Shouldn't it be the other way around? It's not the open shell.
Not necessarily, right? Because you can have variables in the local environment which are not part of the global environment, but not the other way around. Because like if you define something to be exported, it's also available in the whole local environment. Because you can print, like, for example, when I have here a defined message here in my shell, right? I can still access it using this. So that means it's still part of my local environment.
But having global environment be within the local environment would imply the opposite. It would imply that it's a subcategory of local, so that whatever's in local is in global.
I mean, sure, yeah, you can. I mean, sure, when you go for like the natural meaning of the word, yes. But like, I mean, in this case, it's basically more like meant in terms of like local is your locally protected one, and global is your global outlet, what you allow like other people to see. Because the logic here is more like for file permissions where you have like user, group, and world, right? Which is like public or other. But like, I mean, you could also say like, well, the user is part of the world, but like you can still like kind of give it different permissions. So that's kind of the logic that's here implied. All right. However, when we look at source script, actually something different happens. And that is, when we source a script, we basically run all the commands in it, which effectively means that we take the environment of the script and put it into our shell. So is it a good idea to source a script? Well, the answer is, it depends. So if you run commands and you know exactly what you're doing, you can do that. It just can save you time, right? Because you basically just saved all the commands you want to run into a file and just execute that file, and you know what's in there. However, when like some good friend of yours sends you over a script and you're too lazy to take a look at it, check that all the commands don't do something bad to your computer, you better shouldn't source it, because what this could do is basically just override all your settings that you have in your current shell and kind of ruin it in a very bad way. Hence, if you source a script and something weird happens, you basically have overwritten your defaults. And how this works is kind of the following. So, for example, I could write a new script, let's say attack.sh, right? And here, I just write a variable user equals cline, so this will overwrite my user that's predefined by the shell. And then, and of course I give it again the line, chmodit, and run it. And so when I now print the user, okay, it still does tux. I think I have to export it. Oh, okay. Sorry, yes, thanks. That's the reason. All right, so now we should have, if we go user, we have cline. Thanks for the hint. So yeah, and by that we basically just overrode what we have in our current environment. All right, moving on in a nutshell. So this is basically like export and import. So with export, we pass variables to a script, and with source, we can basically fetch variables into the shell's environment. Yeah.
Why does source work when you didn't have information?
I think it would complain. I mean, the,
When you ran source on the other thing that didn't have the execute permission, it worked.
so I mean, we can try, right? We can just give it read only. So I mean, I would say it should complain. Okay, no, it doesn't. So it seems like read permissions are sufficient to kind of source a file. But I mean, of course, I mean, it should complain when I have, yeah, like no permissions at all. Yeah, then it complains. So read is sufficient for source. All right, that brings us to the next topic, and that's operations on variables. So the basic operations one can do is integer operations, and now there is like multiple syntaxes in Bash how you can do that. One is you can use the command let, which basically is let and an expression, and so it will execute an expression. Or you can do like double parentheses, which also executes the expression, or another one, which is like the $sign and double parentheses and expression. So let and like the first parentheses are actually the same. They just basically run the expression. Whereas when you do the double parentheses and a $sign, the result of the computation is returned. And unfortunately, these operations only work for integers, but integers are still very handy. And so we can do a lot of things with them in Bash. That is, we have like all our kind of standard operators. We have like first the basic arithmetic ones. We have bitwise operators, and we have a category of like Boolean operators, so all the logical negation, comparison, equality, inequality, and an OR. So it's pretty similar to like a C-like language, like whatever, Java, C, C++, and so on. And then we also have some more special operators, which is we have post increment, decrement, pre-increment, pre-decrement, and of course a bunch of assignment operators. So basically just doing the same as the operator by assigning it to the variable. We have the conditional operator, which is basically the same as like in C, which works like basically a short syntax for an if-else statement where, well, if the expression is true, then this is evaluated, and else this is evaluated. And then we have another special operator, which is the list operator, which I will talk about more in the next lecture. But bottom line is, it's all the standard operators as in a typical C-inspired language, which comes at no surprise because, as we all know, Unix and C are very connected in their deepest heart. So let's have an example how this works. Well, we can define a variable x equals 42. Then if we just echo it, 42 is the result. Now we can basically add 42 to this variable. We do this by the let statement, so we just write like x equals x plus 42. And the important part here is to basically see that here there is no white space in this expression. That is because Bash does like kind of this weird thing of like splitting commands according to white space. However, there's one way to use white space in your formulas, and that is you can just put quotes around them. And then I said like there's kind of the other option of just using the double parentheses. So we can use that to decrement x. We can also use white space for this syntax. And if we want to run something a little more complicated, we can also run like first like something like a equals 3, then b equals 4, and then we just compute kind of the squares to get like kind of the Pythagorean number out of it. And we can just print it out again. Or we just use, in the last one, the ternary operator to kind of clamp here our variable c to like the range 10 to infinity. And so the difference here is that basically when you just use the parentheses, no result is returned, it's just evaluated. But when you use like the $sign and then the double parentheses, the result of your expression is returned. The next part, yeah.
Why did hashtag equals?
Sorry, which?
When you're assigning echo x at the top, you have echo x.
Okay, so here I just declared the variable, and echo $x is basically nothing else than print out the value of x, and the value of x is retrieved using the $ operator.
But then there's the hashtag after that.
The hashtag is the comment. So this is just like for you to kind of illustrate what the output values are. Right. So we talked about arithmetic operations, and the next important thing are string operations. And so the essential syntax is we can actually just use variables as part of strings. So for example, we know that we have home as our home directory. So if we want to go to the path relative to home, which is like in a folder .local/bin, we can basically just write .home. So this will expand to our home directory, and then just add like these. So we would land basically then in this path if we have like Tux's home directory. However, when we look at the syntax, there are like some issues. And that is like when we just take like the dollar to expand the variable to its value, what is actually the variable name? And the kind of example where I want to demonstrate this is like this here, which is like what is a variable in a sentence. And that is like theoretically a could be just a variable we want to expand, or like a variable or any other substring basically starting from here. So this is one problem. The other issue is like sometimes we just want to do cool stuff and define a variable which has as actual content $home, so we need some way to escape the dollar. And the other one is like, well, what about white space? And we already saw that they're like kind of these quotes. And so because this is an important topic, there are actually a couple of slides for it. That is like how quoting works in Bash. So in Bash, there are like 3 types of quotes. There are like double quotes, single quotes, and backticks. And each of them has actually a different semantic meaning. So I think like most complicated one is actually double quotes. And this is because they do something which is called string interpolation. So they format and expand strings within them. Easier are single quotes, because single quotes just basically treat all characters which are like located in between them as literal values. So there's no weird string interpolation or substitution going on. And backticks are also pretty straightforward, because what they do is nothing else than they take whatever you write between them, interpret it as a command, and return the standard output of the command as a result. So how does it work? Well, let's start, as always, with the easiest case, which are single quotes. So as said, single quotes just treat every character within them as literal value. So that means I can basically write whatever I want in there. There's one exception, and that is like I can't write a single quote itself in like a single quoted string. So again, how does it work? Well, I can use my echo command. I can write something. I can write all kind of symbols, and then it just prints me out that string basically. However, I can also do some more advanced stuff. For example, I could start a story. So for example, this is a story about a penguin. Then I want like kind of a new paragraph, so I can just enter new lines. And whatever, do something like he doesn't like sea lions per se. Right, and if I kind of end my story with a single quote, then this is like interpreted now with like kind of new lines. So, it should work. Was there any mistake? Oh yeah, what was my error? Well, I didn't do something quite well, and that is like I included here a single quote. So exactly the case what I should not do. Luckily, however, in English I can spell it like this. So now it works, and I get back exactly what I expected, and that is like my story spanning multiple lines. So basically, yeah, what this means, it preserves all the characters except the single quote, and we can use it for multi-line strings, as I just demonstrated. Yeah.
Could you escape the apostrophe if you needed to?
Yeah, there is a way. I'll show you in one of the next slides. Right. Speaking of quoting, let's go to double quotes. So double quotes also do preserve the literal value of a character, meaning you can write white space. However, there are like some exceptions, and that is like if you have the following four special characters, something else happens. That is like first we have the dollar, and so if we write something dollar and a couple characters after it, it will perform parameter or variable expansion. The backtick performs command substitution. We can escape these characters, however, with like a backslash, so that's why it's also kind of a special character, because if you want to write a backslash, you actually have to write two backslashes. And then what is kind of also important is the exclamation mark, because this does something which is called history expansion. And so that means if I do something like hello world, exclamation mark, because this is just cool, it works. Interesting. It shouldn't work. Interesting. Okay. All right, here we have another GNU Linux instance. So if I run this on my MacBook, then it will complain. And it will say bash exclamation mark event not found. And that is because history expansion is activated on my Mac, but I deactivated it on the GNU Linux machine, which I use to demonstrate stuff. All right, so how does the parameter string interpolation expansion thing work? Well, I have here another example, which is like basically I define a message, I can echo the message out. And so what this does is basically nothing else than it will replace the message with like the contents of the variable because I used the dollar for it. And there is one more cool thing to notice, and that is like when I have kind of the problem which I had before of like a variable in a sentence, right? What's actually the variable identifier? I can solve this by basically putting the variable identifier, which I want to be expanded in the string, with like curly braces. So how does that work? Let's see again a concrete example in the GNU Linux machine. So I can define a message, something like this. I can just print it out, or I can do the same using kind of string expansion or string interpolation. So I can write whatever secret message is, and then I write just message. And so what this will basically do is just put the string Tux loves ice cream into like the secret messages dollar message string. And so if I kind of want to solve this problem of like a string like this doesn't work because it just prints it goes on. And what's the reason? Well, this basically looks up a variable which is called message end, but there is no variable message end, so it's empty, and so nothing gets printed. However, when I put message into curly braces, the whole thing works, and I have like kind of added the string back into my double quote format.
So can you put the dollar sign inside of the curly brackets, or you don't do that?
You can do that. Then it's like kind of just a nested expansion.
So it'll still return the same thing as if you put the dollar sign outside of the curly brackets?
Let's check. So
Or like, what if you remove the dollar sign that's outside of the curly brackets and you just keep the one that's inside?
I mean like this?
Yeah.
Yeah.
Oh.
Then this will happen. Which kind of makes sense, because what you basically do is you treat the curly braces here as literal characters, and then you just put in that message, right? And because kind of it's not an alphanumeric character, you can delimit what your variable identifier is, so there it works. However, in the other case, it complained, and what was the reason there? Well, I guess the problem is that basically you can't define a variable named like a dollar sign, right? It has to be alphanumeric, so then it complains about bad substitution. All right, speaking of, Well, the dollar character is actually what is a very powerful thing in Bash. That is because it does all sorts of cool expansions. So we already saw one, which is like kind of the dollar curly braces parameters. And so here it basically substitutes wherever it's like put the whole thing with a value of parameter. And there are actually like a couple more expansions this can do, some of which I will talk about in the next lecture. However, the one I talk about in this lecture too is command substitution. And that works by just using parentheses instead of curly braces. And this is nothing else than using backticks. So, for example, I can have here an example where I have echo list returns and then backticks ls. So this will be replaced by the standard output of list. I can write it the same way as like in this example here, where I just have like the backticks now replaced with like the dollar and like parentheses. So these are really just the same. And why this is useful is basically you can build all sorts of complicated strings. Like for example, the current user is $who am I. So who am I is a command which returns the username. And I can kind of check that with like dollar and then here user, which is like the predefined shell variable. So to kind of sum the whole thing up when it comes to quoting, there's one way to combine them. And that is, I can just basically quote parts of a whole string. So in this example, what this does is nothing else to escape a tick, which is like here in double ticks. I just have to simply surround it with like a double quote. So just want to demonstrate that because I think it reads a little confusing. So I can do to escape, then I kind of end my first string. Now I just use the double quotes to escape the tick. Then I start a new string with like single quotes. And here I can just use the double quote. And so I basically get just this sentence back. All right, before we move on, I just want to hand out one specific note on white space. And that is like, if we define a string, like for example here params equals file.txt dest, this is still a string in the bash sense. So that means if you retrieve the value of it, it will be file.txt white space dest. And so pass to a command, this will basically just literally expand it, meaning you have written nothing else than basically what you would have like copy dest source syntax. So this can be useful if you want to, for example, just basically unroll a string into arguments for a command. And quoting basically solves this issue because what it does is nothing else than disabling this automatic unrolling behavior, right? Because what you get here is basically this gets expanded to that, but then it's quoted. So it is, when you would write it out without quotes, nothing else than like just the whole thing with like a white space in it. So the second argument is missing, and that goes like for all these cases. So you basically have here disabled this behavior. So it really matters where you put quotes in the end. Yeah, as I said, it's just a way to specify strings. Kind of the simplest example is you have the two words, and I mean, this here basically will just print params, and this here will substitute it with the value of the variable params. All right, we have another topic. So I think the lecture goes to 5:20. However, before I go to passing input, I think let's do 2 minutes of break. So we'll continue at 8 after 5.
Ask you a question.
Yes.
You said that when you choose the thing that creates notifications, that's the command subshell.
Yes.
That's not the same thing as a shell. Like, it looked like it was printing as a shell.
Okay, so of course it's like this. I even have the title I'd say like
So- It's like logic. So you have the shell.
slides.
And then, because their standard operating straight up, you kind of just focus on results. But technically, it's a separate process, logic development, and that's a subshell.
You say it like right.
So
You say it like
it's
just
just random. Logic, it's kind of not
I had a long run. You have to make a drawing.
I probably need
Wanna come?
Yeah.
It's in I'm going after this class.
Tuesdays are a lot. Tuesdays and Thursdays are too long.
Well, Liverpool. Is it just single star?
I don't know.
So how did you add friends?
But no, it's like I need volleyball. Unless I CH mod and this extra permissions. I do 777. It's over. Wow. What is clinic?
Is there a Wednesday from like 1 to 12?
Alright, good. In the interest of time, let's continue for 10 more minutes. And so this is like kind of the next question which naturally arises when it comes to writing scripts. And that is, how can we pass input to them? So there are basically 4 different ways how we can pass input. The first one is we can pass it as parameters, similar to any command or program that we executed so far, like copy or so, right? I mean, it just always take a couple commands. The second option is we can pass it using the standard input, similar to when we do like piping, right? So we can basically then use our scripts as part of like a pipe or a pipeline. The third I already demonstrated, and that is like we can use environment variables to pass information to a script by just defining or exporting the variable. And the fourth option is also interesting, and that is like we can actually create an interactive prompt within our script, which kind of stops execution, asks for input from the user, and then resumes execution of our script. So how does it work in detail? Well, first, easiest option first, and that is passing parameters. So, I mean, we pass them basically again just as like words separated by white space, and we can access the nth parameter using $, curly braces, and n. And because it's sometimes a little cumbersome to write the curly braces, if the numbers are lower than 10, we can basically just omit those and like write it directly. And if a parameter doesn't exist, it is basically null or like an empty string. Second option is we can use standard input, and for that, I kind of want to introduce something new when it comes to that. We already had like kind of the file descriptors, 0 to 2. However, when the terminal starts up, it creates 3 separate special files, which can be found under /def/standardout, and then kind of the same for standard error and standard in. And we can use them as normal files by just like writing and reading strings to them. So for example, if we do like echo hello world to standard out, what's the result? Well, let's check. Of course, hello with like 2 L's. So if we run this does nothing else than printing it to like the terminal, right? And I mean, I can do the same using like standard error too. And so why this is kind of cool is because we can use that now to fetch input within our scripts. And one way is to just use like the device file stored under like dev standard in, or we can also just like kind of swing by some command which already exists, for example cat, and we know that cat reads standard input if no parameter is given to it. So we can also just basically do command substitution, right? We know cat per default is connected to standard in, so if we just get the result of the cat command, this is basically other standard in. So the script would then basically print whatever you would pass it as input file. And that's kind of cool to write a script which you can use within a pipeline. The other option is environment variables. So basically, yeah, you just have to export it first, and then you can just access it as a regular variable in your script. However, of course, if you define a variable with the same name in your script, it will take precedence over like the one that's like exported, because it basically overrode it. And the other interesting option is there is a special command called read, and what this command does is nothing else than it will start a prompt, and then you can basically save the output to a variable of this prompt. So you just do like -p, you can specify a string that will appear as your prompt, and then it will save the result of that in answer. Same works too for like multiple variables. And speaking of multiple variables, we always have to remind ourselves that how kind of bash splits a string into arguments is always by white space. Meaning, so if you write multiple words in the prompt that you asked for, it will basically be returned as multiple arguments, and you can basically just like add those as a list to like read, and so you can get like basically there are multiple arguments out of it. All right, I know this is like a lot of information, and it takes a while to get used to it. However, I guess many of you will have right now kind of this picture in mind, right? So long as thanks for all the fish when it comes to quoting. But the good news is we have another lecture which will go into some more details on scripting, and we'll talk about some more advanced tricks and tips and control structures. And after that, we will be in a very good shape to write a lot of cool and powerful scripts. And some of those are part of homework 2. So homework 2 should be out today. There will be scripting involved. And my kind of advice is, if you're stuck, please get help. We have enough TAs to help you all. You can also come to my office hours. And in any case of doubt, manual bash is your friend. Right, thanks, and see you all on Thursday.